Hello students. So in the previous class we were discussing about electricity. So we saw what is an electric current. So in this class we will discuss about potential difference. So what do you mean by potential difference, or what do you mean by voltage? So when you take any battery or any cell, so which is used in maybe in watch or in clocks or in TV remote, in so many places they use electric cell or electric battery. So even in cars they use battery. So you must have seen something written like 5 volt, 12 volt, 10 volt, so many things. So what do you mean by this? So this is nothing but this, when you want to rate, this is 5 volt, V-O-L-T, volt. So this is the SI unit of potential difference. So then what is potential difference? So it is nothing but the amount of work done to move charges from one point to another point in any conductor. So it means that there is some amount of work that is done to move a charge. So when you want to write the expression V, so you define or you represent potential difference using capital V. It is W by Q. So W here is work done, Q it is the charge. So work done to move charge from one point to another point in a conductor. So what is the SI unit of potential difference? As I told you earlier, the SI unit of potential difference is volt. So both are represented same. So even this is capital V, this is also capital V. The SI unit of work, it is joule. So we have studied in class 9. So the SI unit of work is joule. The SI unit of charge, that is coulomb. So if you want to define 1 volt, so it means that 1 joule by 1 coulomb. So when you want to write or when you want to say what is 1 volt, so it means that when 1 joule of work, so you are doing work, so when 1 joule of work is done to move 1 coulomb of charge through a conductor from one point to another point, so then we say that 1 volt. So before this, like if you want to understand even better what is a potential difference, so it means that, so when you take two containers, when you connect a pipe, so let's say that in container A and container B, in container A there is a water up to this level, but in container B the water is only to this level. So what happens? So there is a difference. It means we can say that there is a potential difference. So what happens is, because of the force, this water starts moving here. So the water flows from this point to this point. So there is movement of water. There is some work that is done. So the work that is done is moving this water from this point to this point. So similarly, there is work done, and the work done is so that to move the charge, coulomb, that is charge from one point to another. So here also work is being done to move or to shift or to transfer the water from one point to another point. So work is done to move the water from one point to another point. So here also we can say there is a potential difference. So only if there is a potential difference, there will be movement of water. If there is no potential difference, there will be no movement of water. So let's say one more condition. So in second condition also, so if in both the containers, if the water level is same, both the containers shape, dimension, everything is same. In both the containers, if we take water level to be equal, then there is no movement of water. So only if there is some potential difference. So if we decrease the water, even though this is above this point, but what happens is some amount of water starts moving from here to here up to some point where both the water level becomes the same. So since there is a potential difference, there will be movement of water. So similarly, what happens here is, only if there is a potential difference, the electron or the proton or the charge carriers move from one place to another place. So this potential difference in any electric circuit is provided usually by batteries. So as I told you in the last class, battery is represented like this. So this is positive terminal, this is negative terminal. So only when you connect battery, there will be flow of current. So what is this battery doing? So this battery is trying to push the charge and the current flows. When you don't connect this battery, there is no flow of current. So this is creating a potential difference. How? From positive to negative. So the current flows from positive terminal of a battery to the negative terminal of the battery. So only when you connect positive and negative, only then the current flows. So when we take one more situation where there are two batteries. So this is also 5-volt battery, this is also 5-volt battery. When both are connected in such a way that the positive terminal is again connected to the positive terminal, in this case there will be no flow of current, because the potential difference in both the batteries are same. So there is no movement of charge, so there is no flow of current. So this is what happens when you take two batteries. Suppose, say that I am having two batteries. This is positive terminal and this is negative terminal. So when this is positive, this is negative. So when I connect positive and positive, and when I connect wires to the either side, there will be no flow of current, because both of them will be at the same potential difference. Similar thing happens when I connect negative and a negative. So when I connect both negative and negative together, even then there will be no flow of current, because both are at the same potential difference. Current flows only when this is positive, this is negative, this is positive, negative. So when I connect like this, since this is a positive terminal, so the current starts flowing like this and comes to the negative terminal. So if you want the current to flow, then this is not possible. So this is possible. So if you have two batteries, then this is how you need to connect. So positive, negative, positive, negative. So only when you do such connection, the current flows. If not, the current will not flow. So I repeat, potential difference is the amount of work done to move charge from one point to another point in a conductor. So when the potential difference is same, there is no flow of charge, or there is no flow of, it might be anything. So even when you take, you can take another example where, so this is one case. So even like water level also, when you can take water level, or the air movement. So when the air is blowing, so if the strength is the same, so whatever the object is at the middle, it won't affect, because when the air blows from this side, you get one more, or there is one more, the air direction is coming from this side also. So what happens if both the strength are same, and if both are coming with the same volume, or if the speed, everything is same, whatever object is in the middle, it will not affect, because this wind or this air is having the same capacity. So when it comes and hits the object which is in the middle, it will not be affected. But when the air is blowing in this direction and you get one more air in this direction, so it will make a difference, because both will add up, so it will get affected. So only when the potential difference is there will be a moment of charge. If there is no potential, if there is no difference in potential, then the charges will not move and the current will not be constituted. So in the next class we will see about Ohm's law, which is very important. So there are many concepts which are based on the Ohm's law. We will see what is a resistor and many more things. So thank you. Have a great day.